Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, again to another episode of our show, bringing another really awesome guest today involved in creating a better tomorrow. Today, we have the honor of being joined on the show by Elizabeth Reynolds, who is Managing Director, United States of Starburst Aerospace, which is a global aerospace and defense startup accelerator and strategic advisory practice focused on the current aerospace renaissance that's occurring, looking to align early stage technology innovators with government and various commercial stakeholders and investors to help modify the infrastructure in space, transportation, communications, and intelligence. And her team works along literally hundreds of technology startups developing everything from new aircraft, spacecraft, satellites, drones, just to name a few things that she's involved in. Elizabeth brings over 15 years of experience in deep tech entrepreneurship, growth, and business operations and strategy to their team. Prior to joining Starburst, she served as an executive for various biotech, medtech, mobility, and interactive media companies, from founding through IPO. She's also an advisor to a number of startups and nonprofits that support STEM education. And the Starburst organization has offices all over the world, from LA to Washington, Paris, Munich, Singapore, Seoul, Tel Aviv, and Madrid. Has grown into a global team of 70 dedicated team members with a portfolio of over 140 startups, and really focused on disrupting this industry and working towards safe, green, and more connected worlds. I wanted to have with us a lot to get into today. Elizabeth Reynolds, thank you so much for taking time to come on the show.
My pleasure. Thanks for having me.
It's great having you. Would love to, as we typically do, hand you the floor for a few minutes just to introduce yourself a little further, because you've had quite an interesting run in a variety of industries. Would love to hear your background story and everything from how you made it from biotech to medtech to mobility and media, and what got you interested in aerospace ultimately. Love to hear the background here.
Yeah, in an industry where people often still take a very linear path, I most certainly have not. My formal background is biology. I studied heart development in alligators, which is very applicable in the everyday world. But I joined the dark side and transitioned from research into business when I joined a science center program back in 2007. And since then, I have my career has really been focused on helping companies grow and scale. And with traditional businesses, that looked like new products, new locations, international expansion. And then I transitioned over to the startup world about 10 years ago at this point. And I have kind of maintained that focus. So I've worked across a number of industries, but really primarily been working with founders to help them define their own strategy in the market and scale up the business. So I definitely was bitten by the entrepreneurial bug. I love the startup environment, and I actually met the team at Starburst back in 2015. And when I moved back to LA, I reconnected, and I became really inspired by not only everything that's happening in the aerospace sector today, but by all the work that Starburst was already doing, and by the opportunity to expand on that, and both expand the services, the support that Starburst provides for entrepreneurs, as well as being able to expand the number of entrepreneurs who I directly get to support. So I initially came on board to expand the innovation programs that we run and build programs that have that more traditional kind of curriculum basis, the traditional kind of startup boot camp format, and then took over the US business about 2 years ago. But as far as how I got here, I am a very mission-driven person. I want to say yes to things that are interesting and difficult and have the opportunity to make a difference in the world. And there are very few sectors where there is more opportunity to have impact today than when we look at what's happening in the aerospace sector.
Reminds me, when I talk to some of the folks from an organization like DARPA, and all this sort of the traditional stuff that venture capitalists look at, and the time they take sort of goes out the window, and sort of the core thing is, are we working on something cool here that ultimately will be cool once it changes the world? And that's sort of when I go to your website and sort of look at your bio and many of your teammates, it seems like you're all sort of on that same wavelength. So that's pretty cool by itself. But that being said, talk a little bit about Starburst. I know it was founded back in 2012. You define yourself as a sort of this accelerator of startups, and you're involved not just in advising companies, but you're involved in sort of the venturing business as well. And obviously aerospace is core to it, but you have a wide range of clients as well. Can you take a little time to walk through a little of the history of the organization and what the organization's all about?
Yeah. The truth is we do a lot of things. And so it's sometimes difficult to succinctly describe, but at a high level, we're an innovation partner for the A&D industry, focusing on enabling innovation through entrepreneurship. And so we do that in many different ways. A lot of our brand was built around this startup accelerator function. We have internal to ourselves an accelerator that we have been running since 2015 that focuses on helping companies at a growth stage. And through that program, we have built a pretty robust portfolio. We have a portfolio of about 140 companies through that. And we have Starburst Ventures as well, which is an early stage investment firm. We have about 10 investments there that we stood up Starburst Ventures about 2 years ago. Outside of that, what we primarily do is work with other stakeholders in the industry to help legacy players really understand what's happening with the emerging technology space, how to navigate engagement with entrepreneurs, how to simplify processes and build new paths to engage with startups, as well as try to navigate some of the complexities of the contracting process. The actual integration of the technology is perhaps the most difficult piece in the market today. And that has changed. When we first started, we actually started as a more traditional strategy consulting firm, but again focused on the emerging technology space and trying to bring some of the benefits of the open innovation culture to the A&D industry. And we used to have to really shine a flashlight in every dark corner to find 150 startups who were building for the sector then. And there are thousands every year now of new companies coming online. And when we talk about aerospace, when we talk about aerospace and defense, we use that term very broadly. We're really working with people doing everything from really traditional, satellite propulsion things, new aviation solutions, to a lot of enabling technology. So everything from advanced computing, quantum, AI, also looking at some of the other points of intersection. And so you'll see, I have spent a lot of the last couple of years really building our practice around the intersection of space and biology, looking at both the opportunities that the space offers as a laboratory environment and continuing to use space as a forcing factor for innovation, as it has been broadly for many years now, as well as the support we need to continue to expand space exploration.
Just, we'll get to sort of, the themes of health and space age shortly. But when it comes to, as you're mentioning, and for those listening, these are not small players that you're dealing with. So, everyone that's listening and watching can go to Starburst website and check out sort of the range of programs. But when you have things like, this Explore Hydrogen program where, you're working with Singapore Airlines and Singapore Airport, as well as some accelerators. You're working with this Hensoldt, which is a multinational corporation, focused on sensing technologies, and specifically there in sort of the future combat air systems accelerator. You go to, just in general terms, obviously don't give away any secret sauce here, but how do you go about sort of setting up some of these accelerator systems, let's say? Do you get the big player on board first, and then, or do you go out and you look at a lot of the smaller venture players and then, wrap them up and bring them to a major player like a Singapore Airlines? Walk us just through a little bit of that, sort of what typically goes on in crafting one of these, because you've done it many times, so it's quite impressive. And again, I recommend everyone listening to go check out the website, which of course we'll have the link in the bio of the show.
Yeah, it really varies a lot, and I do also think that it's shifting. Again, when we first started this work, we had many hills to climb just to get people to understand what was happening when we were looking at innovation coming from startups and why it was important to pay attention and how this might change the industry. And I think that has shifted. And today, people really understand that critical technology is coming out of the startup ecosystem, and that that it is necessary to engage with that community to continue to maintain strategic advantage. And whether that be from a government perspective or from a corporate perspective, there are some of these same pressures, and everybody is trying to navigate this new environment, which is increasingly dynamic, increasingly diverse. And so what we really, everything is built off of relationships, and we spend a lot of time engaging with all the different stakeholders in the industry. And so these things kind of are born almost out of a necessity today for a lot of our partners. And we do work really widely with a lot of different entities. We're currently working with NATO on Diana, which is their defense innovation accelerator for the North Atlantic. We do a lot of work with NASA, including the new space age space health program that you mentioned. But we've done a lot of work with them in the past, helping to form and scale up Entrepreneurs Challenge, running the MSI Space Accelerator, looking to translate technologies from universities out into the commercial market for dual use. And we work with large corporations, so both the traditional A&D primes, as well as large multinational corporates who are seeing some of the new opportunities that are emerging today, especially looking at the space sector. This is a completely new opportunity, and it's a new economy, and we're starting to see space be integrated into our everyday lives in a way that makes this opportunity seem very tangible and realistic for people broadly. And so there's a renewed interest and a lot of excitement, and people are looking for different ways to engage.
Yeah, let's journey over to the biologic side of things. And again, in this space age write up, and we'll go into more detail of what's going on there. But you outline clearly something a lot of us are aware of, but we don't see it as much. I mean, I've talked to folks like Samantha Weeks, who's involved in the R&D for the Polaris Dawn program in terms of looking at radiation, and Jen Fogarty at Baylor. Obviously, we touched on the theme of, hey, once we get up there, things are kind of tough, and it's not just about supplying oxygen. There's radiation, there's issues with gravity, there's all sorts of other biologic issues that come into play. Where are we in 2024? I mean, clearly you set up the Space Age Accelerator because we have a lot more to do there. But sort of talk, because it seems like, we're doing pretty good at getting new fancy aircraft up there and satellites and all sorts of technologies. Has the pace of space biology, in your opinion, sort of kept up, or is it kind of lagging a bit today? Because it seems like, and clearly, I'm happy everything you're doing with the Space Age Accelerator, we'll be getting into that, but sort of, has the area of space resilience and the biotechnology to focus on it not been there as much as it should have been, let's say, as we sit here in 2024? Give us a little bit of background there.
I'd say there really hasn't been a need to do to expand our capability there until very recently. This is obviously an area that NASA has studied very carefully and rigorously over the years to protect the lives of people going to the ISS and to enable research on the ISS. But until this point, that was a very small set of individuals who were concerned with these opportunities, and that has changed quite rapidly and is going to continue to change in ways that it's kind of it's hard to assess the scale of that change today. But when we look at the commercial space stations, the commercial LEO destinations, CLDs as we call them in the industry, coming online, we're looking at in the next 10 years having maybe 4 or 5 space stations in orbit, which is a great increase in the number of people who will be in space, the number of people who will be in space at one time, the diversity of people who will be in space, as well as the opportunities that we have to facilitate R&D. Though initially many of these new CLDs will be smaller than the current ISS, they have plans to expand once in orbit, and will eventually have a not only a more comprehensive laboratory environment, but the ability to actually manufacture things. And when we talk about space tourism, that also adds an entirely new element into the ecosystem. And so we really do need to be able to support people who have pre-existing conditions, people who don't look like the traditional NASA astronaut, and provide not only a safe environment, but an enjoyable one, which is a completely new proposition. There have been a number of companies who have come into the market in recent years that are what I'll kind of loosely call research satellites, that are providing increased capability, increased access to space today at a lower cost for research that needs access to space but doesn't need a human involved in the loop. And so, there are a number of examples like that. Outpost Space, who were invested in with Starburst Ventures, Forge, Varda, and many others. And so, what's happening as we see this, and as we look at all the work that SpaceX has done over the last handful of years to reduce the cost of launch, and what will happen in the next few years with Starship, what's happening is that it is really actually becoming affordable to go to space. And so whether or not you want to send up a small biological sample, or you're planning to build a space station, getting what you need into orbit has become realistic and affordable in a way it just never has been before.
So, space tourism, lunar exploration, future missions to Mars. We need acceleration of space health sciences, hence Starburst Aerospace, Space H. You know, obviously brought together for this one a very interesting set. Obviously, you know, working with NASA Human Research Program, Trish, the Translational Research Institute for Space Health, Microsoft. That's, you know, an interesting partner in the process. Clearly, a major innovator and investor there of all sorts of technologies. Talk about, you know, again, how, you know, this is obviously the inaugural year, but talk a little bit about how, you know, you went about setting up this is sort of initial cohort of partners for this, and then we'll get into a lot of what the research program is going to be all about.
Yeah. And in my previous answer, I really addressed the LEO economy, low Earth orbit, and everything that's happening there. But you're right, there are entirely a new set of challenges and difficulties, opportunities when we talk about going back to the moon, when we talk about going to Mars. And so that was really the driving force behind a lot of this program, is how do we build kind of the next generation system to support human well-being, health, you know, crew functionality on these longer missions, on missions where you are truly untethered from Earth. Because today, a lot of the support that's provided for the astronauts on the ISS is supported through real-time communication with the Earth, and you have easy resupply options. If somebody needs to return, they can return. It's a different set of parameters when we're looking at these longer range missions. You know, Mars will be a 3+ year trip. And so you really do need to look at how we build systems that are completely autonomous, that can function without support from Earth, that can do everything from, you know, monitor and manage crew health, look for subtle changes in biometrics, look for novel solutions to problems if they do arise, recommend treatments, and you need to be able to manufacture things in space as well. And this is when we talk about space being a really remote environment. In these cases, again, where we're looking at a 3-year mission, again, you have to have everything with you. So you're either anything you need for that 3 years, you have to bring, find, or make. And so that make solution becomes increasingly important with these longer missions because it's impossible to bring everything you need. So we're looking for novel ways to manufacture pharmaceuticals and therapeutics as well. And this is, you know, coming back to the earlier point, there have been until pretty recently, a relatively small pool of people looking at the challenges around having human bodies in space. And so this is something that we've been talking about a lot over the last couple of years, and working to kind of align stakeholders and to bring more resourcing to this. I think that this coalitional model that this program was built with is a really important one. And I would really like to see more work, especially for innovation programs, being done under this coalitional model, because it brings together not only the stakeholders who have, you know, the most extensive history of knowledge, in this case, NASA, and bringing together Trish acts as somewhat of the funding arm for NASA HRP. So Trish, on their own, puts out a large number of grant and proposal opportunities for startups to help advance their TRL and get plugged into the system. And so we're looking to kind of take that base knowledge and take some of this existing network and expand it wildly, because we need to bring in new people to the ecosystem, and we need to be working with not only the entrepreneurs who are already today thinking about space, but all the others who are working across the biological fields, who are building technology that has an applicable use. And we're super excited to have Microsoft joining as well. There's a lot of complexity in building in the system level autonomy here. And so it needs to, that includes everything from, you know, synthetic data to computational biology. There's just to build a system that really is truly autonomous and one that is accurate enough that can be trusted. That's a difficult task, and so we're really leaning into some of their expertise on that side.
Absolutely. And we enjoyed, a couple of years ago, I profiled Dr. Jeff Ling, who had recently stepped down from the Biologics Technology Office at DARPA, and he specifically was working on, at the time, sort of this on-demand pharmaceutical stuff. If somebody in Afghanistan or whatever needs drug X, the ability to zap it and have a machine manufacture it. Again, a perfect example of what you're talking about. You can't bring all 50,000, drugs that we have in pharmacies here up into space with you. So, these concepts are extremely refreshing. Again, not just, the creation of, hey, an interesting drug that helps in radiation resistance, but how we get it there, how autonomy and AI, allows a procedure to be done. It's an extremely, extremely cool portfolio, and it's so refreshing to see someone thinking about all the issues. And again, I recommend everyone listening and watching to go check out the spacehealthaccelerator.com website.
If I may,
go ahead, please.
I want to kind of add a follow on from your prior comment, which is you mentioned Afghanistan, and I want to really emphasize that all of these technologies are things that will make our lives better here on Earth. Like we're talking about space again as a forcing factor.
Absolutely.
Space is the most remote, the most resource poor, the most isolated environment, and so that is forcing us to develop new capabilities to facilitate this, but these are things that will also allow us to provide better medical care for people in resource poor environments here on Earth.
Yep.
And we're looking at a future that is increasingly unknown in some factors, an increased number of environmental catastrophes, and bringing resilience into the way we treat people and manage disaster response is really important. And as well, we're looking at the World Health Organization talks a lot about what we need to do to try to achieve health equity. And the key piece of that is self-care. And not in like a self-help book sort of way, but enabling somebody as an individual to, again, monitor their own health, get diagnostic, have therapeutics recommended, and do that outside of a large medical facility, because we will never have equal access to advanced healthcare facilities. But if you can enable some of that capability remotely for people, you then come to a place that begins to look like a more equitable distribution.
Absolutely. I know, obviously, we mentioned this is the inaugural year. There's a 2024 Space Age program timeline, which sort of just, there was an application window, which I think is closing soon. But where are we right now? Because there's going to be some selection coming up in a couple months, and then sort of rapidly heading into the acceleration process. What's been happening so far in 2024 per the application window, and milestones or important deadlines that are coming up in the coming months?
So applications are open until June 16th. So there's a little bit of time left there. We definitely are still want to hear from people who are building applicable solutions. So I'm happy to answer more questions about that separately, even if people want to follow up with me. But broadly, today, a lot of the time has been spent in really, again, aligning on what the needs are of the industry, where there's opportunity to have impact, and what's well aligned with what's happening in the commercial industry. No matter what agency you're looking at, historically, it has been sometimes difficult for governments to really communicate the needs that they have and the solutions that they're looking for. Often these are part of a large, complex system, and so we see requests or proposals that are requesting a very specific widget for a pre-described solution to a known but not communicated problem. And so part of the work that we do is to really help drill down to what is the widget that you want the commercial industry to make, but what role will that widget play? What difference, what impact does it have, and how can we ask for solutions in a more open-ended fashion? Because we are looking for solutions that also have a use in the broader commercial market, not only because space today is still small, but because even in 10 years when we have potentially 5 CLDs operating and we have these extended missions happening to the moon and Mars, there will still be a relatively small number of people in space. And so the number of items that NASA, for example, would order relatively small. And so we're looking for companies who understand this need and can see the strategic advantage of developing solutions for space, but can then take that advantage and utilize it to their edge here on Earth. So we're very much looking for solutions that have a terrestrial application as well. And so that's been a lot of our time at the beginning kind of formation period, is really aligning on what these needs are and where the commercial market is best suited to solve that for them. And certainly looking at things like AI, for example, there's a huge amount of activity happening in the commercial market today, a huge amount of capability. And so that's a really logical place for us to really lean on what's happening in the entrepreneurial landscape to look for solutions. Once applications close, we'll go through and do a review of those applications. We at Starburst will be looking at that commercial viability piece, looking for teams who understand what it is to build a business and who really want to build a product. And then on the scientific side, we will be having the scientists from the different NASA elements and Trish look at the applications and assess them for the specific mission fit as they see them coming. And the program will run September through December. Exact dates have not been set yet, but roughly that time period, and that'll be a 13-week program with a curriculum base really focusing on, again, how do you get the core pieces of your business in place that allow you to scale more effectively? What does it really take to build for space? How do you fly a payload? How do you strategically frame this work within a longer timeline? All of those components, and we really rely heavily on our large global network for all of these programs. I certainly do not know everything, and we bring in experts from many different fields to come in and share what they have learned directly, hands-on in the industry, to provide really deep subject matter expertise for people working on specific solutions, as well as just to expand network. It's really difficult to build a startup, and there is a huge amount of support that's needed. And part of what 13 weeks is not a lot of time, but part of what our goal is for that is to just as rapidly as we can expand networks so that people have the support they need a year down the line as they continue to grow and scale.
Awesome. You in this first cohort, are you considering only the space health technologies, or are you also going to be considering sort of adjacent technologies in the sense, and thinking about things like obviously every tissue engineering technology that comes your way probably now in 2024 has application in the synthetic stem cell meat industry possibly, and creating innovative foods that astronaut, well, we need down here, but astronauts may need up there. For sort of the computational biology space, we might find interesting things that have to do with genomics of stuff that you may grow on Mars one day, synthetic biology space. Are these part of the process now, or are these going to be separate accelerators?
No, those are absolutely part of the process. And this program uh, specifically tailored, and a lot of the work will be one-on-one to help entrepreneurs who may not have previously considered space be successful at building for the space industry. And there's a huge diversity in the topics as we wrote them, and there is room to submit outside of those predefined topics as well. We're definitely looking for unique solutions. And again, there's so much amazing stuff happening in biotechnology broadly today. There are certainly I'm really excited by everything happening in synthetic bio, and yes, there are a lot of applications for long-term space travel there. And so yes, we're open to all of that. Priority will definitely be given to those who can define how their solution addresses some of the specific needs for these long-range missions. Again, NASA has done a lot of work in this area, and so there are things that they know work better than others. But the hope is that we through this process bring new people into the ecosystem, diversify the pool of entrepreneurs thinking about the space economy, and really maybe find some previously unforeseen solutions. Right? We're really, that is, I think, the major benefit of working with entrepreneurs is sometimes you can be really pleasantly surprised by a solution that you had not previously considered for a problem. And that's really what our goal is, to facilitate a point of entry for those people.
It's gonna be a cool process reviewing all these different technologies and companies as they come into your sphere. I got to ask you one thing. I mean, while I have you, because I'm a big science fiction fan, and you mentioned the Mars journey, which is going to be a long one, and obviously everything beyond Mars is going to take even longer. I've done shows in the past on suspended animation, on cryptobiosis. I saw that you volunteer with Alcor. Looking out, let's say, beyond space H and some of the next generation stuff that we need for whether we're going to Jupiter or beyond. What else gets you excited technology-wise? Because clearly there's a lot of other cool things the movies have taught us for the last several decades that we still need to really become a spacefaring race. What else gets you excited when you think about that the area?
I mean, there are a lot of things. I think a lot of it comes back to that question of how do we how do we have everything with us that we need? How do we manufacture in new ways? And that's not just pharmaceuticals, that's everything that we need. And we're starting to see solutions come into the market today who are looking at not only, for example, capturing space debris, but finding a way to recycle that, to basically have refineries in space that allow you to build new material. And really looking at just how we build at a genetic level, coming back to the synthetic bio piece, like how do you build new composites, new materials, and really use everything well. Waste is a huge issue today. And again, this is one of those things where from the ISS, there are regular return missions, but how do you make sure that you're basically building a system that is as close to zero waste as possible for these longer missions? How do you really reuse everything that you can reuse? These are all really interesting questions, and there's still I'm really excited about, again, some of some of the opportunities, much further out as we talk about like what it would really take to terraform a new planet. Right? These things are still sci-fi today, but they may not be for super long. And again, there are people working on this today. Interstellar Lab, which I absolutely love, which is another one of our companies, is building completely closed system processes to building biopods that allow for the growth of really rare plants in any environment that in an environment that is so carefully controlled that you can cause these individual plants to express certain genes at a higher rate, to trigger certain components to be developed by these plants, right? And so when we start looking at solutions like this that really change the way that we think about life and the way we support life, again, those have a lot of far-reaching implications, not only here and across the world, but in further space exploration as well.
Mm-hmm. I love the idea of terraforming, and I had Craig Venter on a couple months ago, talking about all these interesting genes that he's been discovering from these extremophiles. And I know we have sort of planetary protection laws now and all that stuff that we can't go contaminate, these planets, but be cool to pick the moon that we do some experimentation on somewhere that because I think people always. We'll talk about aliens, but we got a lot of really cool alien-like creatures here that may be able to do some interesting experiments for us on some of these other planets and moons. So I love thinking about this stuff. So it's all really cool. So what's clearly there's the schedule for Space H, and you were just talking about that, and we'll send everybody to your website. But what's coming up for you? Specifically in the coming months of 2024. I see in a couple of weeks you're going to be at Bio talking about Starburst. You've been it was Summit 2024. Other things that are headed up in the next couple of months that we should know about, places that we could run into you, listen to you, possibly meet you. Anything else on the calendar for you or Starburst that you want to mention? Please take the floor.
Yeah. Well, blessedly, we're coming into summer, so the number of conferences has diminished a little bit in coming months. But yes, I'll be at Bio down in San Diego the first week of May. I'm actually really excited about that. Kate Rubins is on my panel, who is absolutely my favorite astronaut. She is amazing. She's a microbiologist who sequenced DNA in space, as well as we have folks from both Bristol Myers Squibb and Merck who are going to be joining in a discussion of really what the strategic advantage is of manufacturing pharmaceuticals in space. And I think this is a really important discussion to have, again, coming back to like the long-term economic play of building for space. And this is something that the entire space industry is relying on. We all see the opportunity to do better science in space, but this needs, we really want bio to be a major player in that LEO economy. I'll also be at ISS RDC, the ISS National Lab Research and Development Conference, the last week. It's right at the very end of July, beginning of August, and that's out in Boston this year. And is another one of my favorites, looking at what the opportunities are for R&D today in space and in the near future, and really what we need to build to continue to sustain that both from an economic perspective as well as from just like a pure science perspective.
It's going to be fun. I look forward to continuing to follow you and see what comes out of this initial cohort per the space age. And yeah, I really wish you and the team the best with it, because it's clearly the direction we need to be going in to, as you say, expand this aerospace renaissance that's happening all around us. So, big fan. And it's going to be fun doing a follow-up with you down the line on how everything's evolved. Again, for everybody that is going to be listening to this particular episode of our show across the various podcast networks or watching on our YouTube channel, again, you've been spending time with Elizabeth Reynolds, Managing Director, United States for Starburst Aerospace, doing really amazing things to champion this next generation of companies that's going to be pioneering the aerospace renaissance all around us. Elizabeth, I really want to thank you for taking the time out of your schedule to come talk to us and introduce us to what you're all about. Obviously, thank you for what you do, and as we like to say on our show, thanks for helping to create a better tomorrow for everybody via what you're doing here. But really, a great story.
Thank you again for having me.